Next thing we're going to be looking at is elimination. Okay, for elimination, what we're going to want to do is we're going to want to eliminate something, just as the name implies. So if we're looking at an example, perhaps like 5x plus 2y equals 8, and negative 5x plus 9y equals 14, we have our two equations here. And we're going to want to try and eliminate either x or y. One of our variables, we're going to want to just eliminate it. So we only have one variable to work with, makes our lives a little bit easier. So if we look here at our first equation, we want to ask ourselves, okay, what can we add or subtract from this equation to get one of the variables by itself? So, we could subtract 5x from both sides, then we get like 2y equals 8 minus 5x. So then we still have our x and our y floating around in the same equation. So what can we do? Well, actually the answer is staring us right in the face. It's right here in equation 2. We can actually just add these two equations together. So if we just add equation 2 to equation 1, we'll end up with this. 5x minus 5x is 0x. 2y plus 9y is 11y, and 8 plus 14 is 22. So then from this we can see easily y equals 2. However, if we backtrack here, why can I just add two equations together? Actually, we have this really cool property of addition called the addition axiom, and that means that if you have two things that are equal to each other, if you add equals to equals, then their sum is equal. A lot of equals in there, but basically what it's saying is, since we know negative 5x plus 9y equals 14, and we know 5x plus 2y is equal to 8, when we add this quantity to this, so when we add negative 5x plus 9y to 5x plus 2y, we know that their sum is going to be equal to what these two are equal to individually. So 8 plus 14. So that's how we know that we can just add two equations together. So now that we know what y is equal to, even though that we're not doing substitution, we can still use our good friend substitution to solve the mystery as to what x is. So we can plug this value of 2 in for either the first equation or into the second equation. I typically like to use the one with smaller numbers just because it makes life a little bit easier for me, but you can use either of these equations. So I'm going to use the first equation, but I invite you to try it out with the second equation to see if you get the same answer as me. So if we take our first equation here, we have 5x plus 2y equals 8, but we know y is equal to 2, so we can do a little bit of a substitution. We can take 5x plus 2, and then what does y equal? Y equals 2 equals 8. So then we see 5x plus 4 equals 8, which means 5x equals 4, and finally x equals 4/5. So now it looks like we have solved our linear system, and we know that the answer to this linear system is 4/5 2, which means that we have one solution. And if we were to think about these two equations graphically, we would know that when we graph them, they would intersect right at the point 4/5 2. Once again, you can check your answer by plugging these two values of x and y into both equations to make sure that all checks out, okay? Okay, for our next challenge in elimination, we're going to be wanting to solve this linear system. So once again, what we're going to want to try to do is we're going to want to eliminate either x or y from these equations by adding the two together. But before we can do that, we want to make sure that our x's and our y's are kind of aligned. So that kind of helps us when we add these two together. We see, okay, the x's go together and the y's go together. Right now, this 3y is on the other side of the equal sign, so it's not going to help us. So we're just going to rewrite our second equation here over here. Okay, so now that we have this one, to solve this using elimination, we're going to want to add these two equations together to eliminate one of these variables. So we eliminated x in the last video, or the last example, so let's try and eliminate y in this one. So what would we have to do to this equation in order to get a negative 6y here. So what we can do is we can multiply this whole equation by negative 2. And I'm just going to rewrite that down here. And we'll see, just recopy down our first equation, because we're not doing anything to that one right now. And then our second equation, after we multiply it by negative 2, every single term in there by negative 2, we're going to end up with this equation. Negative 4x minus 6y equals negative 10. And now we can do our eliminating step to get rid of that pesky y. And then just adding down 4x plus negative 4x is 0x, plus 6y minus 6y is 0y, and 10 minus 10 is also 0. So then we're left with 0 equals 0. So this means that we have solved our linear system equations because we have found 0 equals 0, which reminds us, hey, these two actually are the same lines, so we have infinitely many solutions. Infinitely many solutions does not mean that any value of x and y will work. Instead, it means that any value along this line will work because of the same line. So for example, we know the point 1, 1 works because 4 times 1 plus 6 times 1, this is just plugging this value in here for equation 1, we know that this equals 10 because 4 plus 6 equals 10. In the same way, we know that 2 times 1 equals negative 3 times 1 plus 5. We're using equation 2 up here because 2 equals negative 3 plus 5. However, if we thought, okay, well, does 2, 3 work? Which is just another random point. Then we would have something like 4 times 2 plus 6 times 3. See if that equals 10. So we have 8 plus 18 equals 10. So we have 26 equals 10. Yeah, no way, Jose. So we'll see that this point along this line will work, but 2, 3 does not work. So now we have officially solved our second elimination problem, and we are all equipped to go solve linear systems of equations. So as you go out into the world and solve linear systems of equations, don't be afraid if you run into a linear system that has more than 2 equations. These are just the basics of solving those larger systems, and luckily later on in linear algebra we'll learn a way to make this process go by a lot quicker instead of having to do all this manual substitution and elimination. But also keep in mind as you're solving these problems that we do have a lot of choices to make. So you can kind of make this your own. You can either choose the first equation or the second equation to isolate your first variable in substitution, and then you can choose in elimination which variable you want to eliminate. You can also choose when you're looking at a linear system what method you want to use, substitution or elimination. So really this is all up to you. So now go have fun using these basics, and we'll catch you next time. Bye.